phrase electron configuration refers to location of electrons in the atom, specifically what shell they occupy. Electron shell closest to the nucleus is considered to be the first shell, and then we count outward. Second shell, third, fourth, and so on. Electron shells vary in the amount of energy electrons must have to occupy them. The first shell closest to the nucleus is the lowest energy shell. As we move away from the nucleus, the shell increases in energy. Electrons that are further away from the nucleus have higher amount of energy. To move from low energy shell to higher energy shell, electron must absorb energy. To move from high energy shell to lower energy shell closer to the nucleus, electrons must release energy. Electrons fill up their shells level by level, starting from the first shell closest to the nucleus. First shell can only hold 2 electrons maximum. If an atom has more than 2 electrons, they must occupy higher energy shells. Second shell can hold up to 8 electrons. Once the second shell is filled up, the remaining electrons will go to the higher energy levels further away from the nucleus. When electrons are located as close to the nucleus as possible, the atom is said to be in its ground state. When electrons absorb energy and temporarily move away from the nucleus, the atom is said to be in its excited state. Electrons fill up their shells level by level, starting from the first shell closest to the nucleus. First shell can only hold 2 electrons. If an atom has more than 2 electrons, they must occupy higher energy levels. Lithium has 3 electrons, 2 electrons on the first shell, 1 electron on the second shell. Carbon has 6 electrons, 2 on the first shell, 4 on the second shell. Neon has 10 electrons, 2 on the first shell, 8 on the second shell. Second shell can only hold up to 8 electrons. Once second shell is filled up, the remaining electrons will go to the higher energy level. For example, sodium has 11 electrons, 2 on the first shell, 8 on the second, and 1 on the third shell. Phosphorus has 15 electrons, 2 electrons on the first shell, 8 on the second, 5 on the third. This is the ground state electron configuration of these atoms. Ground state electron configuration can be listed on the periodic table. Ground state of electron configuration of sulfur is 2-8-6. 2 electrons on the first shell, 8 on the second, and 6 on the third. If one or more electrons will absorb energy, they would move away from the nucleus to a higher energy level. Now, electron configuration will be expressed as 2-7-7. This atom of sulfur will be called excited. Neon's ground state electron configuration is 2-8, 2 electrons on the first shell, 8 on the second. If one or more electrons move away from the nucleus because they absorb some energy, new electron configuration can be something like this, 2-7-1 or 1-8-1. There might be variations on that. It is important to understand, in the excited state of an atom, electrons appear on the higher energy level before low energy levels are filled up.